Alrighty, folks. Today we are going to talk about phase changes or changes in states of matter. All right, our learning target for today is I can describe what happens to a substance during a phase change. So I want you to go ahead and set up your notes. Our topic today is phase changes, and our essential question is how does matter change between states? All right. First thing that we're going to do in your notes is actually you're going to open up into your packet, and in your packet, you are going to find this triangle. So you can either take notes directly on this triangle in your packet, or you can draw this into your notes, and that will work as well. But let's go ahead and take a look at the phase change triangle. All right. So what we're looking at here is our three main states of matter: solid, liquid, and gas. And what we're going to do is we are going to identify what it's called when you move from one state to the other. Now, as we do this, I'm going to encourage you to use two different colors. I'm going to be using green and purple. Feel free to use whatever colors you have available. So let's start out with this. When we move from a solid to a liquid. Okay, so I'm going to do this one in purple. So if you're going from a solid to a liquid, that process is called melting. I'm just going to put it right here on this arrow because when we move from solid to liquid, that is called melting. And so when you think about melting, you can very simply think about a ice cube. And if you hold an ice cube in your hand, it goes from a solid state to a liquid state and it melts. Next, if you are going from a liquid to a solid, the reverse of melting, that is called freezing. And we're going to do that in our second color. So if I take that liquid water and I put it into a freezer and I let it get cold enough, it will go from liquid to solid and become an ice cube. So that process from liquid to solid is called freezing. Now, let's go ahead and look at the processes between liquid and gas. So if I take a liquid and I heat it up enough, it's going to begin to turn into a gas. And actually, we have a general term for this called vaporization. Now, I know what you're thinking right now. Hey, that's called boiling when I heat up water enough to go from a liquid to a gas. And that's true, but it turns out you can actually go to a liquid or gas at multiple temperatures. If you go to from a liquid to a gas above a liquid's boiling point or at a liquid's boiling point, that is called boiling. If you transition from a liquid to a gas below the boiling temperature, that's called evaporation. Evaporation and boiling are both examples of vaporization. So we're going to use the term vaporization to describe when you go from liquid to a gas. Now, if you go in the opposite direction, where you go from a gas to a liquid, that is going to be called condensation. Once again, we are switching our colors here. Condensation. So, when you're thinking about condensation, if it is a hot, humid day in the middle of the summer and you have a glass of ice water, you'll notice that all of a sudden the outside of the glass gets wet. And that is because moisture from the air, that gas or that water vapor, is condensing on the side of the cold glass because it is losing energy and cooling down, and so it condenses, and that's a process of condensation. All right, now gases and solids. It's not super typical for us to notice a solid transitioning to a gas or vice versa, but it does happen, and we do have words for it. So let's go ahead and start with going from a solid to a gas. And once again, we're doing purple here. When you go from a solid to a gas, that process is called sublimation. And the only common example of sublimation that you're really going to see is going to be something along the lines of dry ice. So if you've ever had dry ice, you know that it comes in this block and it's actually frozen carbon dioxide. and or a solid carbon dioxide. And what happens is it actually doesn't become liquid carbon dioxide when you put it out at room temperature. It actually goes straight from solid carbon dioxide to gaseous carbon dioxide. And so we call that process sublimation. The opposite direction of that is going to be when a gas turns directly into a solid, and that process is called deposition. Okay? And so deposition, if you the most common example of deposition is in the clouds. When snow happens, you have gaseous water, or water in its gas form or vapor form, and it goes straight from its vapor form, its gas form, to its solid form, and that's how snow comes to be and then falls. So if you're talking about snow forming, that is an example of deposition. What question does the previous slide answer? All right. So before we can continue our discussion about phase changes, we actually need to talk about the role of energy in phase changes, and we need to talk about how energy moves or energy transfer. And in reality, there are two types of energy transfer: energy either going in or coming out. And we have two different words for this. So the first is endothermic. And endothermic is when energy enters matter. And so think about any time that energy is going into something. And so I have that kind of described right here. And if you are going to have energy going into a system, it is endothermic. So, for example, think about a pot of water, and you place that pot of water onto uh, a burner on your stove. And when you turn on the stove is putting energy into the water, and so that water is, or that energy is endothermic into the water. Exothermic is going to be when energy exits matter. Exo exits. And so anytime you have energy being released from matter, that is going to be exothermic. And so you can kind of think about this. If you put your hand up next to something and that object feels hot, that is because that object is releasing energy into your hand. And so the object is exothermic. Now, here's the thing: try not to think about exothermic and endothermic in terms of hot or cold, because whether something is hot or cold actually depends on where the energy is transferring from and to. And so in reality, for hot and cold, you have to have something that is exothermic and something that is endothermic as well. So you have both. And so don't think about it in terms of hot and cold. Instead, just think about it in terms of endothermic energy enters, endo enter. Exothermic means energy is exiting, exo exit. Now, here's some things that we need to know about energy. The more energy you have, the more heat you have. The more energy you have, the more movement you have. And the more energy is present, the more disorder you're going to experience. And all of this comes down to the same thing. Energy causes heat, and in reality, heat causes movement. And then when you have more movement, there's more chaos or more disorder. So energy kind of goes into all of those things. What question does the previous slide answer? All right, I want you to go ahead and turn in your packet to this diagram, and we're going to go ahead and fill it out together. All right, what we're looking at here is a diagram of matter. And so we're just going to start off by kind of identifying what we're looking at. Right here on the left, on our y-axis, we have temperature. On the bottom, we have energy or heat. And the basic premise here is that as energy increases, the amount of heat increases, the temperature of the matter is going to increase. And because we are looking at matter and we're thinking about phase changes, we're going to actually go ahead and label the different parts of this graph as different types of states of matter. So Let's go ahead and start down here at the bottom left. And this increasing part right here is a solid because we know that solids have the lowest energy and are always going to exist at the lowest temperature when it comes to matter. Now, as you add energy to a solid, it can heat up. As you take energy away from a solid, it can cool down. The middle diagonal line here is going to be a liquid. Once a solid gets enough energy, it will transition into a liquid. And that's going to be able to increase and decrease in temperature based on the amount of energy added. You can make water hot or cold. Finally, once a liquid has enough energy, it will transition into a gas. And once again, gases can also increase or decrease in temperature based on the amount of energy you put into them or take out of them. All right, so there's our different states of matter. We go from solid to liquid to gas. Solid is the lowest temperature and energy. Liquid is the middle temperature and energy. Gas is the highest temperature and energy. All we're using is those definitions we talked about the other day. Now, when we're looking at the bottom of this chart here, energy, we go increase or decrease in energy. And as we just talked about, there is this idea that, or we have words for whether you're adding or removing energy. So actually, I'm going to go back to using those colors that I used before, and I'm going to go ahead and use green for exothermic. So exothermic. And anytime I am moving to the left on this chart, it is an exothermic process. And remember, and we're going to use purple, not that purple, for endothermic. So anytime we are moving to the right on this chart, we are being endothermic. So all that means is if energy is being released from our system, it is exothermic, so we're moving to the left. And if energy is being added to our system, it is endothermic, and it is purple, we're moving to the right. So let's go ahead and put our phase changes on here and think about them in terms of how the energy changes. So if we go from solid to liquid, you can see right here that we are adding energy and therefore we are moving to the right, therefore we are adding energy, and that is an endothermic. So we're going to go ahead and write melting in purple because it is an endothermic process. And once again, if we go from liquid to gas, we are moving from left to right on this chart, and we are seeing that that process of vaporization is endothermic. Okay, so what you're seeing, we're just once again visualizing here. If you add energy to a solid and it becomes a liquid, that is melting. If you add energy to a liquid and it becomes a gas, that is vaporization. If you go the other direction and a gas has energy removed from it, and it is going to transition from a gas to a liquid, and that process is called condensation. Okay? And if you have a liquid and you remove enough energy from it, and it becomes a solid, we are moving from the right to the left on here, and that process is called freezing. And freezing is another one of our exothermic processes. So you should be able to identify whether a phase change is endothermic or exothermic, and this diagram kind of helps you with that. If we were looking at this as well, if you're going straight from solid to gas, that process of sublimation, you would be going from left to right, and therefore it would be an endothermic process. And if you were going straight from a gas to a solid, that process of deposition, you would be going from right to left, and therefore it would be an exothermic process, but we're not going to include those on here. Now, here's the thing that we need to identify, and it's kind of an important property of phase changes. As you can see, you can change the temperature of a solid, you can change the temperature of a liquid, and you can change the temperature of a gas, but what you will notice is that there are these flat lines on here. During the phase changes, the temperature, even though we're adding energy, the temperature doesn't change. And that is actually true because you reach, for example, the melting or freezing temperature, and then you reach the boiling temperature. And during those times when they're going through that phase change, all of the energy that you are adding to the matter is not causing a temperature change, but instead is causing the phase change to happen. Phase changes require a lot of energy. And so when you're adding energy to the matter, you're not changing temperature. So that's a really important thing to note, is that during phase changes, your temperature does not change. Only when you have all of one state of matter does your temperature change. What question does the previous slide answer? All right. So now that we've discussed how endothermic and exothermic relate to our phase changes, let's turn back to our phase change triangle. And I hope that you use two different colors. If not, here's what I want you to do. Next to everything in green, you see that I wrote a star, and next to everything in purple, I wrote a check mark. And then up top here, I put purple represents our endothermic phase changes, and green or stars represent our exothermic phase changes. And so it's going to be important that you can identify both or your phase changes as endothermic or exothermic, and being able to understand why they qualify as such when you make that or distinguish them in that way. What question does the previous slide answer? All right, folks, I want you to go ahead and pause the video, take the 4-question quiz, and then come back and we'll go over the answers. What is the name of the phase change between solid and gas? That is going to be sublimation. Energy exits matter. That is going to be exothermic, exo exit. What type of phase change is vaporization? So if you think about vaporization, think about a pot of water sitting on a stove. You have to turn that stove on, and therefore there's going to be energy going into the water, and therefore it is an endothermic phase change. What happens to the temperature of matter as it changes from a solid to a liquid? So remember on our phase change diagram, that temperature only increases or decreases when when matter is in one phase. If it is transitioning from one phase to another, that energy is going to the phase change and not a temperature change, and therefore it stays the same. So if you answered your questions like that, you should have gotten 100%. Alrighty, folks. On a scale of 1 to 5, go ahead and rate yourself. How well do you understand the states of matter? So, if you are needing some help, please feel free to reach out to your teacher, and we'll be very happy to help you. And have a great day, folks.